Alright, continuing here in Chapter 3, we're kind of in AP Stat in Unit 1, mainly focusing in on, right now, different graphs of certain things. And we were going over some dot plots and bar graphs and things like that, and now we're also on histograms, and it says the next type of display that I'm going to be showing you here, and we already kind of saw some earlier, but I'm going over histograms again. It says histograms are useful for large data sets that involve quantitative variables, so quantities, which can show counts or percentages falling either at certain values or between certain numbers. Histograms, normally good for quantitative, so quantities, normally good for numbers. So while the AP Stat exam does not stress construction of histograms currently, there are often questions on the interpreting a given histogram. So they'll show you histograms is what it means. You'll see them a lot. They don't normally construct a whole bunch, okay? But it could change anytime, and it could be on it, and that's why we go over it just to make sure. To construct a histogram again using your TI-84, are we ready? Construct those histograms. You go to Stat, we go to Edit, all right? And you put in the values on your list. So here's the values I'm going to give you. Okay, it's going to give you these values. So put these in. Again, pause the video if I'm moving too fast. That's why I have everything written down. Everything. Just pause the video so you can see where we're at. So let's just say that above, this is our data set, right? And we need to stop the stat plot on, right, by pressing second Y equals. So turn it on if you didn't already, right? So press enter. Now it's on. Right, highlight on, check, all right, and that's histogram, so make sure we choose the histogram icon as well, and you put everything in list 1, right here, so make sure it says here, plug in the items into our X list is 1, that's where you plugged it in, so make sure that says L1. If you wanted to store them, you could have made this an L2, you can make it an L3, just put it in whatever list you want, doesn't matter. It says if you plugged values into list 2, then you would have chose L2 there. But, leave the frequency at 1, and then next press second and mode, because second and mode always quits you back out. That's basically what it means to get you back to the main screen, and everything you just did should be saved in there. So next you press zoom, right? And when you press zoom, it looks like this, and we want to scroll down, right? Because we're looking for zoom stat, so you press on zoom stat, and this is the bar, the histogram, that I get. So there's my histogram, right? Doesn't really look like anything too fancy. It says if you have a line through yours, because sometimes people do. What I mean by that is there's like a graph. Somebody has a graph through it. It's because you probably have a graph like a Y equals there. So sometimes people have to get rid of the functions that they did before when they were taking another course or use the calculator. So you're going to have to get rid of those. But if you have a line through yours, it might just be because you have something graphed in Y equals. Just erase the graph in Y equals and take another look. All right, so just trying to show you how you can create your histograms to see where things are at, but the spacing is the key that you also will have to work on with the histogram, the graphing calculator, to get a better gist of it. And you can go in and change the spacing if you wanted to. That's just the quick, fast way of how to plug everything in. That's all. But look at this one here. Suppose there were 2,200 seniors in a city's 6 high schools, right? 400 of the seniors are taking no AP classes, 500 are taking 1, 900 are taking 2, 300 are taking 3, and 100 are taking 4. So there you go. So we got 400 seniors, 5, 9, 3, right, 1, all that up to 2,200. These data can be displayed in the following histogram, shown, right? None, 1, 2, 3, 4. Okay, so there you go. And then the amount that they have, but right up against each other. That's all. It's a histogram. It's labeled number of seniors. And it wasn't hard. I don't need a graphing calculator to make this work, right? Just kind of put them in the center, and there you go. Right, so there it is. And it kind of looks normal-ish, okay? I want you to get used to seeing that idea now. It kind of is normal-ish, right? It's not even exactly, but it's at least normal-ish. Sometimes instead of labeling the vertical axis with frequencies, it is more convenient or more meaningful to use relative frequencies, and that is frequencies divided by the total number of the population, right? The number of seniors. So it's 1, 2, 3, 4, 500, 6, 7, 8, 9. That is 1,000. So if we look back at the last problem, suppose there are 2,200 seniors in the 6 high schools, right? This is the problem. That's all. Just the same problem we had before. Number of seniors. That's the frequency table, right, of each one. And then I found the percents, relative frequency. The relative frequency as a percent. Those are your percentages, right? Okay. You could label them as the proportions or the percents. Still the same shape. We went over this already earlier in the notes. Still the same shape, still the same everything, right? But just the nice little shape of what we got, right? It's the number of AP classes, all right? And sometimes you can label them like that. Note that the shape, again, is both the same in both histograms. It's the same whether the vertical axis is as proportions or as actual numbers and counts of them. Doesn't matter, it's the same. Let's take a look at another example. Consider the following a histogram of the numbers of pairs of shoes owned by 2,000 women. All right, so look at this. All right, I have the frequencies of both. Here is the counts. Here's the relative frequencies, which is basically like your proportion, right? Your percentage of them. And this is 1, 2, 3, 4%, 5, 6, 7, 8%, right? And this is your counts for it. All right, it works for both. Right? Do we see it works for both? That's 160 pairs of shoes, or number of pairs of shoes. Right? There were the number of pairs of shoes, and that is 160 people stated to have about, we'll say 16, 17, 18 pairs of shoes. That's a lot of pairs of shoes. About 18 pairs of shoes. 160 different people said that. So what can we learn from looking at that histogram? So for example, none of the women had fewer than 5 pairs of shoes. Right, let's see. No women had, none had lower than 5 pairs of shoes. All women, right? Or more than 60 pairs of shoes. Thank the maker on that one. Holy moly, 60 pairs of shoes. Yeah, no one had more than 60 pairs of shoes. Okay, that's good. We also know that. And like I pointed out, 160 of the women had 18 pairs of shoes, which was the most pairs of shoes. Or sorry, the most amount of people had 18 pairs of shoes. 20 women had 5 pairs of shoes. Right, so you can look at all this. So there we go. There's 20. Had 5 pairs of shoes, but they also had 6, 7, 8, 9, 10 pairs of shoes. Right? 20 women had 5 pairs of shoes. Half the total area is less than or equal to 19. And let's see what that is. Less than or equal to 19. And here's how you do it. Just count up the total areas to figure this out by looking at the relative frequencies, right? Look at the table. Or maybe I did it right here. Let's see. Nope. So the point is, take a look at this. This is 1%, right? Right. If this stands for 1%, 2%, 3%, 4%, which means same marking over here. Follow it down. 1, 2, 3, 4, 5, 6%. But then each of these are 3%, right? If I follow it across there, it's about 3%. So that's 1, 2, 3, 4, 5, 6. That is 9. That is 12. 15. That's 18. That's 21. So up to here is 21% of all of them. And then way up here is 7%. 21. So that's 21 and 7 is 28. That is 28 and 7 is 35. 35 and 8 is 42. So yeah, like this is about 49-ish to 50%, and that's right around 19. So right here is 20, so there's 19. So yeah, that is about half of them right there, right? If that makes sense. So I just added up the percents that matched over there on the side, and that's what he said. So half the women have 19 or fewer pairs of shoes by adding up all those percentages. 15% of the area is more than 30, so 15% of the women have more than 30 pairs of shoes. again, count the relative frequencies. That's all I was doing. So you could go back and look at the table again if you wanted to and count those. It says 15% of the area is more than 30. More than 30 pairs of shoes. Right, there's a half. Right, that's a whole, that's a half. So there should be 30 of those marks maybe, and that will count it up. Right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. And there are halves. So there you go, 15%. So just count them all up, figure it out. Just count the relative frequencies. 5% of the area is more than 50%, or 5% of the area is more than 50. So 55 of the women have more than fewer. Like, it's just looking at the graph. That's all I'm trying to show you. You can use the relative frequency part and the counts to get the answers. So let's quickly take a look at another example. Consider the following histogram of exam scores where the vertical axis has been labeled. All right, so the vertical axis has been labeled. What can we learn from this histogram? All right, so there's a histogram. Kind of looks normal, right? But it says, consider the following histogram of those exam scores where the vertical axis has not been labeled. So I don't even know. Nothing there, right? No vertical axis. Don't even know. What can we learn from this? So people look at this and say, well, I don't see there's anything I can learn from this, right? And it is actually impossible to determine the actual frequency, meaning I can't tell you the number. I can tell you what people's scores were. That scored between 60 and 70, sure. Scored between 70 and 80, sure. 80, I can show you, I can't tell you how much. I know what they might have scored between what zone, but I don't know how many people, right? We have no idea if there were 25 students or 100 students in the class, so I can't tell you the actual frequency. So any particular number of students who took the exam could be represented here. However, we can determine the relative frequency, which is like the percentage, by noting the fraction of the total area that is under it. We can divide the area into 10 sections, right? So if I took that and started to draw lines, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 1/10. 1/10 of everyone, which is roughly 10%, fall there. So each one of these is about a 10%. So 40% went in between here, 30%, 20%, that's all it is. So I was able to reasonably get that, right? If each area is about 10%, all right, is between 60 and 70, right there, 10% between 60 and 70. 40% score between 70 and 80, and 30% score between 80 and 90, and 20%. So I can't get the actual counts. I can't get the frequency, but I can get the relative frequency. I can get the percentage is the key behind this. Okay? So we'll continue on here when I come back. But I wanted to make sure that I guided you through looking at the histograms a little better and how you can take that and look at the data, because that's definitely on the exam.